This conference will now be recorded.
Sorry, I didn't get you. Sorry.
Like you have been sharing me the machines, like VMs and
Right,
the machines, everything, correct?
right.
So it was creating a problem for me because uh, it was taking a long time to get it set right. But I have been seeing a lot many VMs and machines for this. So which machine I need to use? Like I could not.
No, actually, you can have the Cloudera or Hortonworks machines, which are available as a ready-made kind of thing. You can just plug and play kind of thing. But the problem is the interface and everything will be different. If you're already having a work experience, so you can work on any virtual machine like Cloudera or the Hortonworks or whatever it may be,
Okay.
right? But this is the first time are not having any prior experience and you're like interacting with that, right? So that's the reason I just have given that provided that at the same time in real time you'll be using you know some tools like putty and all to connect that machine. You don't get an interface like that. So it doesn't raise any question whether you're using Hortonworks or Cloudera or whatever it may be. At the same time, what is your RAM size?
16 GB.
16 GB RAM you having. Okay, then that Cloudera virtual machines will work from your end. You can download and you can work on that, but the interface and everything is different because they'll be using a different interface and all on the Cloudera machines. Similarly, with the Hortonworks also. But ultimately, in real time, you don't get that interface. So just you will be getting, you know, a putty and you're giving your IP address and user ID and password. You are interacting with that Hadoop cluster. So it will give create you a lot of confusion, right?
Yeah.
So it doesn't make any like it will be downloaded because a lot of students are participants I can say who like just they downloaded without any problem. I don't know
No,
why it's
like
creating a
it's
problem
done
for you.
already. But when I unzipping, it was taking a long time for me. Yes.
Hmm. So can I share your screen?
Yeah, sure. Just a minute.
1 second. I'll make you a presenter.
I sent a request to you.
Yeah, I made it.
See here.
No, your screen is still not able.
Yeah, you got it now. You got it?
No.
I've been
Waiting
always
to
saying
it's saying it's a waiting to view Naresh what is that? Deva Bhaktuni screen, yes. It's saying that. I think you have not shared your screen.
I shared you right away.
And I didn't get. It's just waiting like that only. So otherwise, you just stop other running applications if any are running because I think you're having some slow internet connection.
You got it?
No, still it's saying the same thing.
There's no applications running going on, so no downloads or anything is going on right now.
Hmm. See, just I'll share my screen and is it visible to you? My screen.
Yes,
Are you able to see my screen, right? Yes,
yes.
that's fine. So once again, what I will do, I'll make you a presenter, please. Not try with this.
You got it?
No, actually,
No, because I've been because
screen is not.
already I passed it. It was showing me the resume, the screen, past screen sharing or resume, the screen sharing also. Like I was seeing the green symbol.
But I don't know why it's. Actually, it's, yeah, now it's coming. Just a moment. Okay.
So this was the process, like every time, like it's the
So it's
thing.
opening. Yeah, right. So which application you're using? WinRAR should be there, right?
Yes,
So this, I think you are using some other app.
I'm using WinZip.
No, WinRAR is a good one, right? Because it's a RAR file, not the zip file.
Okay, okay.
So just close this one. I'm just canceling this. Don't have that WinRAR with you.
No worries. I can download it from the Microsoft
Yeah, yes.
server.
Yeah, please do it. WinRAR. Yeah, WinRAR. RAR. That's it.
Yeah, put it, but
Yeah, you can go with that. Otherwise, just I'll give you the link.
no, I can. Give me a second.
Oh, these are all not required. Just
Yeah.
fine. Just you can close that. Yes. And don't open that extract. That's it.
No, just I'm saying. Okay.
Okay. Just extract. Yes, extract here. You can say or extract this. Yeah, to the folder. Right. That's fine. That's hardly it will take 10 minutes. So now, do you have that VMware player with you?
Right now, I've been taking everything out, so I need to install one more time.
Okay, if that's the case, I can give you. Otherwise, just you download the free one. It's not a problem. VMware workstation, that one what I'm using, it requires some passwords and all, the serial key and all. But VMware player is a free one only. It doesn't require any
What
passwords.
is it? We can start the class. So in between, I can install the VM and I'll let you know. Okay.
Now it takes only 5 minutes only, not a problem.
Okay.
Right. So you just download meanwhile that VMware player also. I'll tell you.
I think there's some issue with. I don't know what's happening. You can
Mhm.
hear me?
Yeah, I can.
So there's something issue. So we can start. We can start it like in between the break session. We can make it out. Okay.
Sure, not a problem. Fine.
Oh, I'm stop sharing the screen. Okay.
Okay. Right. And one more thing, can you have session on Friday at 6 a.m.?
Friday at 6 a.m.
Yes. Tomorrow,
Yeah.
there is no problem. At 9 p.m. we can have. I mean to say on Thursday, but
No
Friday,
problem. We can have 6 a.m.
yeah, because Friday evening, just from Friday to Monday evening, just I'll be in travel. There's no problem. Monday I can take the session on the scheduled time at 9 p.m. IST. There's no problem with that. But only Friday, just you have to change the session to 6 a.m. IST. That's it.
Sure, sure, sure.
Fine. And right, let me. Okay. Right. So now we discuss a few more joins. So apart from normal joins and what we did yesterday, we do have some specific joins in PIG, like replicated. Let me write here. I'll be taking a new notepad for that so that I can share this later. Right. It's 040919. That's fine. So replicated and skewed and merge. So these are the other joins that we can talk about in PIG. Right. So what is exactly this replicated join? So we do have a concept called a distributed cache, right? We are having a concept called distributed cache actually in MapReduce. Okay, so what happens? What is exactly this principle? So for example, you're having two tables like employee and the department, or the some yes, department table. For example, you're having maybe this employee is having a lot of employee details like employee number, employee name, and maybe that department ID. So like the way they're having a lot of records in this particular table, given table. And coming to this department, maybe it's a something like we can say it's a lookup table kind of thing, which is having only few records. Okay, which is just having a few records. Just we can treat this as a lookup table. It's a very smaller table. So once you're having a bigger table at one end and a smaller table at another end, what we can do, we can push this particular department table into main memory. Okay, for example, look at this. Where is our data sets? Yes, this is the data sets table. So just let me open the data sets first of all. So this is my department table, right? And this is my employee table. So here I'm having employee name, employee ID, and department ID, for example. And coming to this department table, just I'm having 10 positions. Entry level I'm denoting with a number 10 and junior with a 9. Like the way just I'm having some 10 positions in my company. So what I'm doing here, so for every company just I'm denoting with some department ID here. So CEO is recognized as a department 1 and senior manager 2. Like the way just I'm having some positions here. So this is something like lookup table that I can call because it's a very small table, right? And the other end I'm having a bigger table here. A lot of records I'm having here. A lot of employee records I'm having here. So if I'm doing a normal join, it takes a lot of time. Okay, if you're running a normal join, it takes a lot of time actually. So instead of that, what we can do, we are having a concept called distributed cache. Like in the MapReduce principle, I'll tell you very elaborately, very clearly when you're talking about the distributed cache mechanism. Okay, so the same concept, because this distributed cache concept, and we'll be having map, map side joins in Hive. They are also same concept. Once again, repeats, right? The concept is very similar here. So, but the names are different. In MapReduce, we'll be calling our trading as a distributed cache, or in Hive, we'll be talking the same phenomena as map side joins. But here in Pig, we are, denoting this as a replicated joins. Got it? So whatever it may be the name, but the concept is same here. So what we're doing really, so whenever you're having a use case like this, one big table and a one small table, if you're having, just push this small table to RAM, nothing but your main memory. Okay, just push this, just load the small table into RAM. and just perform. Okay, map side join, that's it. That's it. So we are not at all going a traditional processing. What do you mean by the traditional processing? See, yesterday, I was discussing about the conceptual thing, and by the hands-ons also we have seen. So whenever you're executing a particular big job, so internally it has to do a lot of jobs, right? So the moment you have given the statement like dump a store, it's doing physical, logical, then after that map reduce plan, then finally it's going to be processed. So instead of that, in the same manner, when you're running a map reduce script, suppose there is two tables and you want to join those two tables, right? So you have to go with a mapper, reducer, and some other intermediate stages also. So finally to get the result, right? So just we are avoiding everything and we'll be performing everything on top of this particular mapper. Okay, so we just eliminated the remaining steps. Like you can say, if you're talking about the traditional mapper programming, okay, initially this mapper, reducer. Before going to this map reducer, there is some shuffle and sort, something like we calling a merge phase, then reducer, then finally result. Okay, this is a normal four steps we have to undergo whenever you're just performing a normal join. But if you can go with this particular replicated join, we're just performing this everything on top of the mapper itself. So we are removing, or we are eliminating, not removing, we are just eliminating the remaining steps. So we make sure that everything is happening at mapper end. Okay, everything is happening at the mapper end. So we are not using the additional steps so that we can optimize and we can go with many minimal resources here. Okay, so meanwhile, just I'm not going elaborately, but while explaining these map side joins in Hive and distributed caching mechanism and MapReduce, I will be giving the clear-cut elaborated explanation for this. At this moment, just understand that we'll be eliminating these additional steps so that we are optimizing the thing and we'll be getting the result everything on top of the mapper. So mapper is the only guy who is responsible to join your data. Got it? But problem with this technique is this is only applicable once you're having a small table and once the end you're having a bigger table, right? If you're dealing with a very big tables, so your main memory is not sufficient to handle the situation, right? So that's the reason the principle only applicable whenever you're having a bigger table at one end and a smaller table at one end, and the smaller table will be pushed into main memory and you will be joining everything. A cache will be created initially and hash maps will be created. Okay, that create explanation and everything I'll give you in Hive session. But meanwhile, just understand once you're applying the replicated join on the given data sets, so this join operation will be performed at mapper level. So we are not at all touching these steps. So you're getting the result. That's it, right? So we'll perform initially the replicated join, right? Then after that we'll understand the skewed as well as merge also. So let me do that. So what is the first step I had to do here? Whenever I had to work with PIG, what I had to do, I had to copy the data sets to HDFS. So that is the first step I had to do. So I'm copying the data sets by saying HDFS DFS minus put, right? And EMP and department. That's it to HDFS. Fine. Now my data is available here. Right. I'm having my department and employee table here. That's fine. So which is just a department table here. You can see the size, it's a 145 bytes. That's it. And this employee table is somewhat bigger than this, right? 3.97 kilobytes. That's fine. Now, That's fine. I think yes, this is the one. Now here we'll write the script for that. Or simple, it's a single line. I can't say it's a script. Instead of that, I can say it's a single line. I can say it's a very simple thing, right? Whenever you want to work with this replicated joins and all, that's fine. Right here. So what's the initial step we had to do? Just we had to take it to relations, and we had to define the schema, and we had to load the complete table level schema to the particular relation. So let us do that. I'm taking a capital E, right, to load my employee data into that. I think it's in a cap, right? EMP using, you can write in lowercase or uppercase, it's not a problem, using big storage. But this should be like this only, capital P and capital S. Remaining all you can keep in the lowercase. Big storage, it's a comma separated values. So I'm giving that comma the delimiter for me, and S, now you just write the metadata or the schema here. So we are having the e name, nothing but employee name, and we have employee ID, and we are having some DID, nothing but department ID. That's it. Okay, this is what exactly we are having in our employee table here, right? So just we give the data types as well here. So this is the char array, and this is the integer, and of course department ID also I'm taking as an integer. That's it. Okay, next take one more relation called D here, and I'm taking the same thing to save the time. So taking, it's a D. So load here, I can say DEPT using big storage, comma, and its e name, of course. Let me verify here. So here just I'm having the department name and the department ID here, right? Let me get the same thing here. So this is D name, I can say department name, okay, and I do have the department ID. Okay, I'll modify this. First field is the department ID, right? Yes, yeah, department name and the department ID, right? So this is the department name and this is the department ID. Fine, that's great. Now we'll do the replicated join. How to join the replicated join? So we just go with one more relation by saying rep get joins. Okay, you can take any relation here. So join E by this department ID, and we'll keep one more thing here, DPT. So join E by DID and D by nothing but my other relation, okay, DPT ID. Okay, then you just say using replicated. That's it. Syntax is very simple, right? It's a single line, that's it. So we are joining two tables. So we loaded the data initially to HDFS. Then after that, for joining these two tables, we are writing this. That's it. Okay. So this is how you can do the replicated join. That's it. And you can say dump replicated join. That's it. So let me go to the grunt shell here. And one more thing, here we are giving some relations or alias, right? E is equal to something and D is equal to something. What is the scope of that particular alias? Here you said E. Okay, right? Now you said D something here. So what is the scope or of this particular E or D, whatever it may be? It will be available till the moment you're closing this session. That's it. Suppose you have closed this. Okay, you have closed this one, and now just you have re-log into this, for example, by saying pig. And what we did actually, we have already given E is equal to something and D is equal to something in our previous relation. Now if you say directly this the third statement, so try to get the what exactly your system is saying. Got it? So mismatched input replicated expected, that's fine. Okay, anyway, we just verify the log and all. So here, because it's not finding what exactly E and what exactly D here. Just a moment. There is something called, yeah, we missed the single quotes here. Right, now we'll see. We have corrected that. Because it's saying here the previous error is different here, right? So previous error is something like it's quoted string. I have not given this in the quoted, so I have rectified that. That's fine. But apart from that, look at this undefined alias. So it's not finding what is exactly this E. It's not able to get that, right? Why? Because what we did, we just closed the grunt shell here. We just close the grunt shell and once again we open that shell. So the moment you close, that's it. The scope of your relations or alias, whatever you can call, that will be ended there itself. So the moment you're opening once again the shell, you have to give that your previous relations or alias, whatever it may be. Got it? So that's the only scope. So that's the reason we had to do as we have Hello.
This conference will now be recorded.
Hello, Naresh. Are you able to hear me?
Yes, sir.
Yeah, just I connected through my mobile.
Okay.
So suddenly I lost the broadband connection. Sorry for that. I just connected through my mobile device. And if you're having any inconvenience in terms of audio or video, please let me know.
Sure, sure.
Fine. So now, we just able to join this because it identified, the shell is identified what exactly E and what exactly D. Now just dump this. Okay. That's it. Fine. Now here you can get the information also. Okay. So here you got the complete statistical information, like how much time it elapsed and how much map time and everything. Here you can see. Here you can see this maximum reduce time here 0. Got it. So map time is showing 13, for some milliseconds or seconds, whatever it may be. Apart from that, if we look at here, the reduce time, it's 0 because we have not used the reducer yet. Okay, so this is the replicated join and it's taking everything on top of the mapper here. Got it? Got the idea here? So it's showing that completely the reducer is 0 here. That is the advantage here. So we're trying to process everything, on top of the mapper only. So we just stop the remaining stuff. So normal joins, that mapper reducer in between, you be having the other phases also. Okay, other phases also. So now you are getting output. Of course, the output will be like this. And yesterday I have shown you, right, how to remove the department IDs and how to keep it in order. That steps you can perform. But our main interest is, just how to join, how to use that replicated join. That's it. Not more that. Is this fine? If you observe this, everything will be working on top of the mapper here. So that is the main thing that you need to understand with this. So we have eliminated this shuffling and sorting and reducer. These are very expensive phases. They'll occupy a lot of memory and they consume a lot of resources and everything. So with the help of these replicated joins, we just completely taken away these steps and finally we got the result, right? That's the purpose and importance of your replicated join. And what about skewed join here? We'll understand a bit concept here. See here, whenever you're working certain data can be balanced or unbalanced. We cannot predict the data. Okay, the data, some data is coming to you. So the data in a distributed environment, it will be balanced or it may be unbalanced also. Then what happens? A particular block is having more data. Maybe the particular reducer which is working on the particular node will be getting, a lot of work, and other data, other nodes, other blocks, like which are having a less data, maybe they're getting a very less works, right? Less work, I can say. Got it? Then what happens? The reducers are not equally distributed with the work. Some is having a huge burden, and some reducers on a different nodes are not having any work to do at all, because they are parsing very less records. Okay, so we cannot say, right, this reducer will do this much like that way. So the moment you're having some unbalanced data and you want to have a good thing, like you want to work, whenever you just identify that there is a chance to have some unbalanced data and all that time, you can work with a skewed join. So what it will do, it just do the pre-sampling, right, and identifies the keys. And what happens then, with the help of this particular skewed data, nothing but the unbalanced data is going to be automatically split into multiple reducers. Got it? Okay, I'll brief for this with a simple thing. For example, we are having 40 members in a particular class, and our, okay, not all like this. Yeah, we're trying to, we are evaluating some student papers here. So there is some panel, panel, 10 professors are sitting in a row. So maybe like 1,000 students are completed their test and they're waiting for the result. And so what we need to do, we need to distribute the answer sheets to the professors so that they can evaluate and they can announce the result, isn't it? So if you're giving randomly, what happens? One professor may get 200 papers and one will get 300 papers, and when one will get the only just the 50 papers and the other guy will get 10 papers only. Then what happens? Particular professor, so certain professors are taking huge responsibility to evaluate the papers here, and some of them are having very less papers. So this is something like an unbalanced situation that you can understand. Nothing but you're having some skewed data. So in that time, what you can do? If you apply skewed join, right? If you're applying a skewed join on this particular data set, then PIG performs a pre-sampling and it just identifies who's like in our scenario, who like which particular professor or which particular professor is having very less papers to evaluate, and it will like distribute once again. Okay, the first guy is having 200 papers to evaluate, and it will take some of the papers from him and it will be distributed to the other guy who is having very less papers to evaluate. I think what it is doing some sampling procedure once it identified. So pig is not actually identified by itself. We are saying we are not sure about that. There is a chance. We are expecting that there is some unbalanced data that we are having. So once we distribute it to different nodes in a distributed environment, we are predicting that. So to distribute evenly the workload to all the reducers, now you can opt the skewed join. So what happens is, pig will do the some sampling activity and identifies the keys, like who are having a very less records to process, nothing but some unbalanced data, so that it will be distributed properly. And what happens then, each reducer will get the equal number of records to process. Got the idea here? What exactly the skewed join? Can I get a quick response?
Yes, Anil.
Fine, great, really. So just for your understanding, just I'll write few points here so that you can refer the same thing later. So here, once again, same thing. I think I lost my audio. It's saying, hmm, right. So skewed means something like, and I can say it's unbalanced. unbalanced records. That's it. We can work on this particular scenario, right? Secure data. Okay. So I can write like this. Pig handles secure data by sampling and identifies keys which have unbalanced records. That's it. By doing the pre-sampling mechanism. Having some unbalanced records, right? So once we apply this join, now what happens? Data is going to spread across or split across multiple reducers evenly. That's it. That's it. Okay. So what's the syntax here? So no problem. Here you can use the same thing. So you can say here SKEWJ. You can give anything. Secure join is equal to join E by department ID and D by department ID using skewed. That's it. So no need to change any business logic because already we have given what exactly E and what exactly D. So every time no need to mention this unless otherwise you're not closing the session. I mean to say sorry, the pig shell. That's it. Right. So just here you just mention skewed. That's it. That's it. Okay, got it. And after that you can say dump sqj. That's it. Dump sqj. That's it. So we'll give these two statements in the shell, pig shell. That's it. Now, oh, where is my branch shell here? Okay, where is that? Fine, here I can give. So let me give this. Okay, sorry for that. I missed out really here. So I can say once again, pick. I forget to give that single quote. It's not taking. So right, we'll wait for some time. It's processing anyway. Here you can see. Taking some time. Right. Okay, meanwhile, we'll understand one more thing called merge. It's taking some time.
Okay.
Okay, it's a completed 83%, of course. But so we understood the applicability of merge join here. Meanwhile, it taking some time. Right. For example, you got some pre-sorted data from your client. Okay, the data is pre-sorted, then you can apply this merge join. So the advantage here is you can just skip the sort phase. You'll be having the mapper phase and reducer phase. That's it. So meanwhile, you're having shuffling and sorting, nothing but the merge phase, right? That's going to be completely you know eliminated or skipped. That's it. All right. I'm repeating once again. Here, if you recollect, I shown you some phases. What has to be internally has to happen, right? Whenever you're doing such an activity, so this will be done internally, right? But if you're having like you got some data is pre-sorted here, data is pre-sorted here, okay, then this particular measurement it can be used. If your data is not sorted, sorry to say, it won't work. It's going to give an error. Your data is not sorted. That's it. That's error you're going to get now, right? We can check that even on the log well. Error will be created. Okay, when you can use this only if your data is sorted, then what happens? You can just you know end with your process with mapper and reducer. So this you can eliminate. Okay, so this can be eliminated, and now everything happens and the mapper and reducer. So finally you're going to get the aggregated result. So this phases is going to be skipped. That's it. The syntax is very simple here. Okay, the syntax is very simple. One here I can show you that also. So here I can say merge join. That's it. MBRJ. So join E by D and DPT by D using merge. That's it. So once I join, of course, you can do a lot of things. A lot of things you can do based on your problem statement, right? And that's it. So now we'll give and see what happens. Okay, you got the condition also, right? It should be pre-sorted. If your data is not pre-sorted, you're going to get error. That's it. It won't work. It won't work. That's it. Right. Anyway, we got the output here, the previous one. So we got the previous. So it's joined successfully for us. Hmm. Here you can see the skewed join what we worked earlier. See here it's showing the reducer time also. Have you observed this? Earlier we got everything zeros here because the map size join what we worked, the reducer absolutely is not work here. Got it? So now here you got some time, right? So it's also process some records and it's having some time interval here. You can see that very clearly. Earlier we just have the map time and we don't have the reducer time. Okay, so the moment once you are executing this QGen, what happens? It will be doing the reducer also, right? That's fine. That's the difference I want to show you. Okay, of course output here will come anyway, that's not a problem, but we need to identify the functionality here. That's fine. Now we work with the skewed one, sorry, the merged one here. So let me copy this. Now we'll see whether it will generate any output or will end it with an error. So let me take this. Right, we'll see. Okay, so Naresh, you are able to download that WinRAR and everything, right?
So, like, can I share my screen?
Yeah, just a moment. Yeah, we'll just verify this error and I'll look into that. See here,
Okay.
it's giving a clear error. You can see this.
Okay.
See here,
Yeah.
yeah, it's not properly sorted, so it's not able to, last two tables encountered. So there is some issue with these guys. So the data is not sorted. It's not in the complete sorted order, so it got the error and generated the log file for us. So this is what happens exactly. So whenever you're doing any merge join, please make sure that your data is pre-sorted. That's it. So
Okay.
here you can see very clearly it's saying data is not sorted on the right side. And it got some problem with these tuples, last two lines, 9 and 10 here. This is the one. So like this, you can get the applicability when to use a particular join and what kind of errors that you're going to expect, right? So this will be, in real time, it's very much useful for you. So once the data is sorted, once the data is joined, okay, now you can start your own, analysis and transformations and everything using the pig handle statements and all.
Okay.
That's fine. Great. Yeah, now I'm making a presenter. Yeah, please share your screen now. Yeah, I'm able to see. So VMware player is sufficient, no need to go with this. So you're using anywhere the Windows only, right? The machine. Don't you find anything like VMware player, say a simple tool? Just say, yeah, please say VMware player. Because the other guys, like what you're showing, they required the authentications and they require actually serial key and all. For player it's a free, that's not a problem. Player. No, don't go the trial one. VMware, this one will be free only. Again, it will ask you after 15 days or 10 days, it will prompt you a password and all. Old one, you can download any old player. Yeah, I think you can download this. No, don't just say no thanks, continue to download VMware. It's not required. There you're getting option, right? Just take me to I think 15 is not the free one. Yeah, otherwise I'll give you a link. I think I'm having in my Google Drive. Just a moment. I'll verify and I'll share it to you.
And, and hello,
Yeah, Naresh.
this one is fine.
Just yeah, just a moment. I'm not able to see the screen. I just minimized and I'm putting share in. Just a moment. Just I shared. Please verify that link. You can download directly.
Then one, then stop sharing the screen, okay? Just for fun sometime.
Okay, just give me 5 minutes. I'll come back and okay,
Okay, sure, sure.
we'll continue the session. And meanwhile, I just share to you to your email ID. Just download that. It's very simple.
Yeah.
So right,
Yes,
Elmesh,
yes, sir.
yeah, can you show your screen?
You got it?
Hmm. Yes, you just download it. No problem. Yeah, it's already there. Okay, fine. So this doesn't require any, serial keys and all. Yeah, just say next, accept, say next, and yeah, it's up to you where you want to keep that. And that's please uncheck that. It's not required. It's on uncheck. That's fine. Yeah, you can keep that. The day your one of your friend, had a talk with me, right?
Yes,
She's
yes,
working
yes,
as a data engineer, she said.
yes.
Okay. So that day she asked about that interview-based preparation and all that and the Spark and Scala.
No, no.
So
Like she was looking for like a full like a training session with. She asked me like in training sessions, like what you are like in training section you can prepare me in the interview point of view also because I was.
yeah, right. Yes, 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 yes. Yeah, that actually I'm busy with these things and that already I am running out of this thing and I have to complete the pre-assigned task. That assignments and also I'm not finding any free time so that
Because
but
she was getting married in October, so that's why she was very busy in October.
okay,
So they're
okay.
planning
So she's from
to go
India?
to India to get married.
Okay, right. So actually I'm preparing for the data certificate, data science certification and all. So I had to give that exam on somewhere in October, planning to go because here in India certifications are very important. I don't know about US, right? In UK market, once again they don't have any. Yeah, they're having preference in certifications, but I think I don't think so. You're having importance in certifications in US, right? Because a lot of the participants they expressed just they don't they just least bother about the certifications. But, yes, I'm not getting a screen. It's a blue something.
Yeah, that's why I don't know what. I'll make it over here.
It's coming here. Yes, in the background. So, yes, just you give your any email ID. It's not a problem. No, no, don't go with that. Yeah, just provide some. Not it has to give the exact one also. Some you can give abc@expedited.com also. You don't verify
What?
anything. You just give any default like abc@expedited.com also. It will take.
Yeah.
Otherwise, simply they'll send some newsletters and some info and all to waste our time. You can give anything, any default thing it will take. That's it. So no need to open a virtual machine. Yeah, just give that path where it is located. The one you downloaded. not here. So yeah, Hadoop next. I have given that. Yes, you just click that one. Yes, yes, that one. Take the ownership. That's fine. Yes. So I think you have opened it somewhere.
Me?
Mm.
No, I think so.
So just say I copied it. Maybe I think you opened that one, right? You just double click down somewhere.
Yes, 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 I think, yeah.
Yes, that's the reason it's saying that taking ownership and all. I no need to
Downloading.
do with that. Remind me later. It's not required anything. It's already there. I just given that. That's fine. The password is Hadoop in lowercase.
Hello?
Yeah, Hadoop. I'll text you. I think you have. So right in the top you're having that right full stretch. Yes, click on here. No, not that one. Let me do that. Let me. Yeah, you can do that even. It works, right?
Yes.
So you can start work here, and after finishing, just you can go with this, you know, by clicking on that and put in the hibernate mode. Nothing but
Shut
suspend
down.
mode. No, don't shut down. If you shut down, what happens? Every time you have to switch on the services, like
Just
name node, data node, and everything.
restart this.
Yeah, restart also same thing. Hadoop server will be down that time. So you can say suspend. That's it. But now you're not having any work to do. If you like in a shutdown or restart, then what happens? You have to start your Hadoop services once again, like the
Oh,
name node, data node, and the other stuff.
oh.
Okay.
This time I'm shut down and like suspending it.
Yeah. Otherwise, you can shut down so that you can practice from the scratch, right? How to start the services and all. You can do that practice. You can shut
Okay.
down it. That's it. You can start later. Okay.
Yes, and also I'm good also. We can continue it. So I'll look at it out after the class.
Okay. Fine. So are you able to see my screen, right?
Yes.
Right. So we'll go with one more scenario here. Yeah. See, whenever you're having some XML data, okay, and you can't say some relation and you cannot load the data to that because your P cannot understand what you said really. Okay, because XML data is having some tags and everything, right? For example, let me show here. You're having some sample data also here. Which one? Hadoop Let me open this. Right. So here I'm having a sample data, some XML data here. So I'm having some records also like this. Right. So it's having consists of some book records here. So some books. I'm having two books in this particular XML data. So one is Hadoop Definite Guide and one is the programming in PIG. And here I'm having some details like author, country and company and price, year and everything here. For example, if you're having such data, you know, you cannot read that. I mean to say your PIG cannot read this data properly because the data is in a semi-structured data. It's having some tags and it's having some data inside. So if you're having a data like this, how to do or how to parse. See, I'm not talking about processing. Processing is different. So when you can process this data, so once you extracted these elements, right? So once you extracted these elements, now then you can start processing. But before that, what you had to do, we had to parse this data, nothing but we had to create a normal plain text kind of thing. You have to extract all the elements and you have to store at the HDFS level. So once the data is HDFS level without any tags and all, then you can start processing. Got the idea? So for this, there is two mechanisms are available in PIG. One is XPath and one is regular expressions. Let me write here. So to parse XML data, okay, in PIG, you can use either regular expression or you can use XPath. Both are valid here. XPath, right? So these are something like they're having these are some functions and having some loaders actually like JSON loaders, XML loaders. So we are having some loaders actually, right? So what these loaders will do, they will understand the pattern what you have given in the given data set and they will try to extract. Of course, for extraction we need to write the functionality, but these functions will understand the pattern first of all and try to create some chunks with that so that we can collect the chunks later and we can put that into a particular order. Nothing but you can make some tuples and you can keep the data in the HDFS. That's as simple as like that. So either whenever you're having an XML data like that, so for example like this, to pass this data, either you can go with regular expressions or with the XPath mechanism. So we'll understand each and everything now. So if you're talking about this XPath, this is a function actually. This is a XPath is a function, right? What this will allows us this it will allows us to extract the text actually. Okay, allows to extract text from XML. That's it. And to do this we need to have something like some other UDF concepts we have to undergo. So the UDF is nothing but user defined functionality. So if you want to use this UDF, what you need to have? You need to have some UDF functionality. nothing but user defined functions. So this user defined functions can be implemented on top of Java. So you can write your own business logic and you can implement how to read the data, how to parse the data line by line like this, and how to extract the elements in between these. So you can write your own UDF. Okay. Alternatively, what we can do, we can use some jars like piggybank.jar. So you can write your Java code here, or alternatively what you can do, you can, let me write here so that it don't confuses you. You can write your own thing, or alternatively you can download some jar files which is already having the business logic, like piggybank.jar, or one more jar we are having, combo.jar. So in this particular jars we are having the definitions for these functions and everything. Okay, so what this consists, so if you're giving a input to this particular XPath function, so what it has to return. Okay, so you can you will be providing input as a tuple and returns a string here. So what this will do, so you will be inputting tuple and it provides the output as a string literal, that's it. Or you can see simply, or you can write simply string. That's it. That's the main functionality which is available under this XPath. So whenever you're giving some data like this, for example, I just consider this. Okay, so this is the input, right? There's the tuple that what you have provided. Then what it provides, it removes the tags and it gives the string for you. That's it. And this UDF functionality about this XPath or regular expressions, whatever it may be, which is available under this piggyback.jar or combo.jar. Okay, so earlier, we need to download this jar files from the Maven repository. Repository called Maven. Generally, the Java people, who are working in real-time environment, whenever they're having certain requirement, instead of running or instead of implementing everything from the scratch, they just depend on the Maven repository. So a lot of jar files will be there with the classes, methods, functions, and everything, so that you can include them in your business logic instead of wasting your time by writing the code from the scratch. So directly you can use the functionality. That's it. You are using some ready-made. That's it. Okay. So already this class and functions, everything defined under these jars and available in the Maven. Okay. Earlier we used to download this from the Maven repository. Right. So it's not at all coming along with the pig. So earlier versions of pig, it's not having really. So we have to download them manually. Okay, we have to download the piggybank.jar or the combo.jar manually, and we have to register them in the pig script. So we don't have any provision for that actually. So we have to download them from the Maven repository, and we have to register these jars in our script. Okay, but afterwards, from the new versions of pig, this is incorporated in your pig itself. So no need to download anything from the Maven repository. It will be there. For example, I'll show you the location. If you go to this home, where is my pig here? Yes, this is the, where is the pig? I'm finding, yes, here. So this is a pig version what you're using. If you go to library, here you can see this piggyback what I'm referring here. Okay, so this jar file has to be downloaded manually earlier, but from the newer bigger versions like this, so this is included, or it's coming along with this, so no need to download anything from the Maven repository. So you can register this path, that's it. Okay, you can register the path where exactly the piggybank.jar is available. That's it. Right, let me close this. Now this particular piggybank.jar or combo.jar are having something like XML loader functionality. Okay, they're having some XML loader functionality here. Let me write here XML loader functionality. So with the help of this functionality, like we can load the data. First of all, this data has to be loaded, right? Because we are having the data in a different format, so this cannot be straight away assigned to a relation. So with the help of the XML loader functionality, which is available under this jar files, right, you can use that and you can load the data first of all. So once the data is there, then you can use any regular expressions or XPath to extract the content. So here I said, right, so your input is a string or tuple that you're providing like this, title and Hadoop definite guide, and it's providing this string as an output. So you can use this. Alternatively, you can use regular expressions also. Okay, so you can use regular expression also. Let me write here the regular expressions. Yes, regular expressions. Same thing. Okay, so same thing. Either you can use these regular expressions or the XPath. The style will be different, but ultimately you're extracting the data. And what are the steps that you need to undergo, right? So these are the some steps you need to please keep in mind. I'll write these steps here. Of course, you know this. Load XML data to HDFS. That's fine. And then you register the piggybank.jar with register statement. I'll show you the script. So you can register this piggybank.jar or combo.jar. Nothing. You have to say just register and you just provide the complete path. Yeah, you can download and you can give the path. Alternately, you can give the pig home path, right? Just now I have shown you that in the pig lib folder we are having that piggybank.jar. You can provide that. Then right, you can say load the data. This load is different, right? I think you know about the first load and the second. I mean, it's a third step load. So load the data. Nothing but you just define some relations, and to the relation just to load the data. Finally, pass the file. Parse the file and just retrieve the value. That's it. That's the only thing what you had to do. Now, as we are having certain thing, right? Like you're having some data, like you're having a Hadoop books.xml file, and this is the data what you have here. And if you want to extract the values, Hadoop definite guide, Tomwide, US, Cloudera, like this. So it's a procedure. So now we'll understand that. So here I'm having already these jars. I have already downloaded from the Maven repository. So I can provide the address or the location of this in my big script, right? Otherwise, I can give this also. Both will valid. Just I want to show you the difference here. Okay, you can give that. Otherwise, what you can do, just now I have shown you right here in the home And the pig installation folder, where is that? Yes, here. Under that lib folder. So you're having a piggy bank over here. So you can give this path also by getting the path. Like you have to specify this path. That's it. In our script file. So just open our script file. I'll show you that very quickly. So both I will show you. One is, the pig XML, sorry, regular expressions and XPath also. This one, regular expression. And we do have the XPath also. Okay, here. All right. Now, so look at here. This is what I'm saying, register. So just you have to say register and just provide the path. Okay. So for example, if I'm using this on my local file system, here I'm having my piggybank.jar. So just get the properties and provide the path, home user desktop. That's it. So this is the path. You just mention that in your register statement here. That's fine. So we done this. Meanwhile, before going further in the script, just let me copy that data set to Hadoop. This one, Hadoop books.xml, by saying hdfs minus put Hadoop books.xml to hdfs. So just I loaded the data to hdfs. And I registered the piggybank.jar also in my script. That's fine. Now, we'll try to understand the script here, regular expressions, followed by the XPath also, I'll tell you. So here, I'm taking one relation, my regular expression A11. You can give anything here. Load, and we said like, Hadoop books.xml because this file is available in the HDFS. Using, now look at this XML loader I'm referring, org.apache pig.piggybank storage XML loader. So this guy will have the complete, this function will have the complete idea how to tackle this particular XML file. So this guy can understand, the function can understand. So earlier, like, we are using pig storage, something like, a comma separator or tab separator, like that we be just giving, right? So here you're providing this because all the way this is very new to pig and pig cannot understand the data what you're providing in this, right? So to store that particular data in a given regular expression, sorry, in a relation, we are just using this org.apache pig.piggybank storage. So this guy is present in this particular combo.jar or piggybank.jar. You can give anything here. So book I'm taking as X is a carrier. Just I defined, a default data type for all the fields as a carrier here. So my interest is just I want to read the data from the starting tag, nothing but the book. Let me open here. Yes, from here I want to read. This is my starting tag. So I have given that from where it has to pass the data. And for all, here I said a simple variable called X here. And the default type I have given as a cat array. So my for all, by default, any number of fields I'm having, those will be given a data type as a cat array. That's fine. So now what happens, this complete data is now available here under the relation called my regular expression A11. That's it. Then what are the fields that you want to extract? So for that, we need to write the second relation. So just I want to go with this, right? My regular expression B variable one. So here I'm writing the pig Latin statements for this. Nothing but I'm doing some transformations here. So for each, my regular expression A11, nothing but my previous relation, generate and flatten extract all. I have used a lot of things here. We'll understand one by one. So this rejects extract all is a regular expression which will extract the tags, I mean, say which extracts the elements from the text, like book title, title, author, country. You're having something, right? So here I said title. This is my starting tag, and this is my ending tag. In between, you're having some value, right? I just put dot star, and I have given the data type as a char array. Now, any field I'm having like this, Hadoop definitely get on where you as Cloudera, all these will be by default given as a data type, you know, as a char array. Now that will be extracted. So that is the functionality of this regex underscore extract all, right? It will be extracting the values which are in between these tags title. There's the starting tag and there's the ending tag. In between you having the value. So like the way all the values will be extracted. Now those should be put in a row fashion. So that will be taken nothing but you have to make some tuples, right? So you have to extract the tuples will be given and you have to get the strings and all. You have to put in an order. So for that we'll be using the flatten keyword. It's just taking the chunks or blocks of the data and putting all them in an order so that now P can read the data. Okay, so P can read the data. And to view the result, what we said, how it passed the data, whether it passes the data successfully or not, we just send a dump and my previous relation. That's it. Got the idea here? So these are the some steps we had to undergo. So just copy the data to HDFS, first step. Second, register your combo.jar or piggybank.jar, either from the downloading from the Maven repository or from the your pig home path. That's it. And after that, define the relation and load your XML data and using this XML loader. And this guy is having, XML loader function is defined under this particular package called org.apachepig.piggyback and storage. And from where you want to start the parsing. So starting, you have to do it from the book. As X carrier, nothing but we just taking all the fields as a carrier here. That's it. Now after that, we'll be giving one more relation. And we are saying for each our previous relation, generate, flatten, and rejects extract all. So this rejects extract all is a function which extracts the data from the tags like this. And that will be collected by the keyword called flatten and keep them in order. That's it. So now all this will be available under the my regular expression v11.1. And now you just dump the data on the console. That's it. Right. So now we'll run this script and we'll see how to run the script. Yesterday we have seen that, right? So just you have to say pig space, okay, and your pig name. So my space regular expression dot pig. This is my script name. So meanwhile we'll understand the XPath also. So here for the XPath also same thing. Just you register the jar file, either the piggy bank or the combo.jar. Let me do the same thing here also. Right. So the registration is over. Then you just say the definition, define XPath and define the XPath and you just provide the package. So watch.apache piggybank evaluation.xml XPath. So here it will exist. So this functionality, this XPath functionality is available under this location. So we are defining a variable. This XPath is a variable. Here you can give your name also. Okay, define Naresh. So Naresh is a function, a temporary function that we can call. Or define Anil, that's it. So we are defining a temporary function based on this functionality called XPath, which is available under this path, under this package, sorry. Got it? So what is this define XPath? We are defining a temporary function based on the actual functionality and which is available under this location. After that we are taking a relation my XPath A11 as usual. You can take anything and you just provide load XML using, now this remains same here, watch.apache piggybank. Earlier also we have used the same thing and we are saying the parsing activity has to start from the book. The default data type is excerpt, that's it, char array. So there is no difference at all there, first thing. And after that, you just say one more relation, and for each your previous relation, generate an XPath. This is the one. This is the one, the temporary function on the given data set. Like, what exactly you want to extract. You're having a lot of things, right? You're having title, you're having other country, company, price, and everything. But here, if you observe, just I ask you to retrieve only the other and the price. That's it. From. So finally, you're dumping this. That's it. Okay, this is how you can implement using XPath mechanism, and this is how you can implement using regular expression. So before running this script, just will verify the output. Yeah, it's provided the output here. You can see that very clearly. Here you got it retrieved all the values, right? So this is the actual value what you're having. I mean, it's the data set what you're having. Now you're able to get the things like this, how the different can tone weight and all that stuff you're getting. Got it? So this is how you can extract using the regular expression, and this is about the XPath. So I'm repeating the steps briefly once again. Just load the data to HDFS and register your combo.jar or piggybank.jar and define any temporary function based on the actual function XPath, which is available under this package. Now take any relation and load your data to this relation using this particular package and the functionality to provide the data type. And here in the second relation, just you are using the XPath mechanism, and you just said what are the fields that you are to required. So just for a sample thing, just I have given the other and the price. So as of your choice, just you can provide all the things. Okay, from this book, you're retrieving the title or other, a country or company, like they just you give all the details. So I want to show the difference here. Earlier, I just extracted all the details, but now here I'll be extracting only few things. That's it. So let us run this script and we'll go through. So how to run the script here? Big space and the script name. That's it. Fine. Yes. Here, look at this. You just retrieve the values, Tom White and Alan Gates here, and the price. That's it. So that's how you can do with the help of XPath. Got it? Manish, any queries here? Can I get a quick response? Have you followed this? Hello. Yeah, Naresh, can I get a quick response?
Yes, sir.
So, right, are you able to follow this?
Uh, a little bit, not that. Yeah, a little bit difficult for me.
Okay. So just go through once again and just perform all the steps. And in next class, please let me know if you have stuck somewhere. I'll help you on that.
Yeah, sure, sure. I'll go through video one more time. So,
Right. Please do that. And if you have any query, please let me know. I'll help you on that surely. Right. So we'll end the show here. And tomorrow we'll see a few more examples in terms of JSON data parsing and simple word control program I'll show you on this big and macros. I'll show you the core reusability concept, how you can implement. And after that, I will start the Hive because I want to keep the UDF concept because it's pure related with the Java. So we'll cover them at a time. So for 2 or 3 examples, it will take some time. After that, we'll start the Hive also. Okay,
Sure
that's
then.
for tomorrow's agenda. Right. So as I think you're having good knowledge in SQL, so you'll be enjoying the PIG and the SQL. I mean to say that Hive sessions also. Hive is more and more SQL kind. So we'll see. Anyway, I'll show you more and more examples on Hive also.
Oh,
So once we're done with that, we can work about the H catalog also. We'll see.
oh.
Fine. So right. Thank you. Bye.